Measures of central tendency. In a previous section, you learned 3 ways to define the center of the distribution. 1. The point at which the distribution would balance. 2. The value whose average absolute difference from all the other values is smallest. And 3. The value whose average squared difference from all the other values is the smallest. This section defines the 3 most common measures of central tendency: the mean, the median, and the mode. The relationships between these measures of central tendency and the definitions given in the previous section will probably not be obvious to you. Rather than just tell you these relationships, we will allow you to discover them in the simulations that follow this section. The arithmetic mean is the most frequently used and well-recognized measure of the center of a distribution. It is calculated by summing all the numbers in the group and then dividing that sum by the number of numbers. In a population, the Greek letter mu represents the arithmetic mean. In a sample, an m or x bar is used. Regardless of whether you are analyzing a sample or a population, the formula is the same. The Greek capital letter sigma followed by an x means to sum of all the numbers. You then divide by n, the number of numbers. Although the arithmetic mean is not the only mean, as you will see later, there is also a geometric mean and a trimmed mean. It is by far the most commonly used. Therefore, if the term mean is used alone, it is assumed to refer to the arithmetic mean. As an example, imagine that 1, 2, 3, 6, and 8.3 shots are made in the 5 starting players on the basketball team. What is the mean number of the shots made? First, sum of the number of shots, resulting in a total of 20. Then divide by the number of starting players, or 5, which gives a mean of 4 shots. The median is another common measure of central tendency. In general terms, it is the exact midpoint of a distribution, meaning that the same number of scores are above the median as below it. Another way of thinking about the median is that it represents the 50th percentile of a distribution. Let's imagine that in your class of 31 students, you score the 16th highest score in the class, say an 80. Your score is the median because 15 students received a score lower than 80 and 15 students received a score higher than an 80. You are at the 50th percentile. The median is a relatively easy statistic to calculate. When there is an odd number of numbers in your distribution, the median is simply the middle number. For instance, the median of the numbers 2, 4, and 7 is 4. However, when there is an even number of numbers in the distribution, the median is calculated by taking the mean of the 2 middle numbers. For instance, if a sample consists of 4 scores, 2, 4, 7, and 12, the median is the average of 4 and 7, which is 5.5. And third and final commonly used measure of central tendency, that is the mode. The mode is the most frequently occurring value in a sample or a population. Imagine that you and 9 other people play a hole of golf and make these scores. Because 3 is the most frequently occurring value, 3 is the mode. With continuous data measured to many decimal places, the frequency of each value is typically 1, since the same score is rarely obtained for more than once. For example, if you measured the time it took to make a response to a stimulus, no 2 times would be exactly the same. How do you calculate the mode when every score has a frequency of 1? The solution to this problem is to compute the mode from a grouped frequency table. This table shows a grouped frequency distribution for response time data. The interval with the highest frequency is 600 to 700, so the mode is the middle of that interval, which is 650.